then I'll share my screen. Okay. Can you see my screen? Okay, so we did this on Monday. So basically, to solve exact equations, we have two methods. So this formula method, and we have what we call grouping method. So the grouping method is not ideal. So when you have a theory question, you shouldn't use the grouping method to solve that problem. But if you have objective, you can use grouping method to solve the problem anyways. But when it is theory, you have to use this method. This I've forgotten the name they call this method anyways. So that's the method you're going to use. Okay, so you know I also talk about having to give out solutions to 3 years questions for math method, right? So as regards that, I wouldn't be giving out soft copy. So I don't know how you're gonna get the hard copy of the of the uh, of the solution. So I can give you the hard copy of the solution. So we can discuss that later anyways, yeah, we can discuss that later. So so let's see, let's start. So can we have a question on exact equation? Can I have a question on that? So let me check my folder and so choose the no, let me check this. So say should the following differential equations are exact and solve them by the comparison method. Yeah, that's the name of the method, comparison method. And the other one is grouping method. So let me start with which one should I start with between 1 to 4? Which one should I start with? Okay, number 1, I have y squared plus x squared dy dx plus 2xy equals 0. So we have y squared plus x squared dy dx plus 2xy plus 2xy equals 0. So apparently, so let me write it in this form, in that form of exact, that form I gave you, right? Something dy plus something dx equals to 0. So if I want to write it in that form, I'm going to have, so I can just multiply 3 by dx, so I can have the y squared plus x squared dy plus 2xy dx plus 2xy dx is equals to 0. So I have this. Now, so what's going to be our m? What's going to be our n? Can you see my report? Can you see clearly?
Yes.
Okay, I'm going to take my m to be the guy with the dx, the guy that has dx, like this component. So my m is going to be 2xy Then my n is going to be the guy with the dy. So my n is going to be y squared plus x squared. So if my m is the guy with the dx, so I will have to find m, I have to differentiate m partially with respect to y. So if I differentiate m partially with respect to y, I have 2x. Do you agree?
Yes.
Now if I differentiate n partially with respect to x, then I'm going to have 2x. So in this case, since your my is equal to nx, then you can come to the conclusion that your equation is exact. Now, since the equation is exact, then you can proceed to solve. So let's start from grouping method. So hence, it is exact. I won't be available next week Wednesday. Oh, okay, next week. Next week Wednesday, I'll be a bit late. I don't know. I don't know whether it's possible. Can we start by 7:30 there about 7:30, or we should just forget about the class on Wednesday, next week Wednesday? He said,
What of Tuesday?
no, I won't be available. Even that, so even Monday I won't be available. I'll be available on Monday and Wednesday. Next week, Monday and Wednesday. Let's have this discussion, Natasha. So hence it is exact. So using grouping method, using grouping method, using grouping method to solve our problem. So what we're going to do is that I'm going to come to this place, this particular place, where this particular place, I'm going to come to this place. Then, so what I'm going to do is that I'm going to expand this guy. So I'm going to expand this guy. So if I expand this guy, I'm going to have y squared dy plus s squared dy, right? Plus 2xy dx equals to 0. Are we still together?
Yes.
So the next thing for me to do is now, I will now put integral. I'll say integrate everything like this. Now, so I don't need to put integral here. So this one is like, okay, no worry, sha. So moving forward. Now, all this one has integral. Now, notice that is y dy, like a function of y and dy, right? Hello?
Yes.
Now, this one is dy, but you have a function of x there. So there's kind of, so anywhere you have dy and you have a function of x or something that is different from y, what you're going to do, you're going to do a manipulation. Say you're going to put half here. So you're going to put 1/2 here. Look at this too. I have dx, but I have a component of y here. So here too, I will put 1/2. But if it's just dy and everything you have here is y, if it is dx, everything you have here is x, then you don't need to put all this half. Do you understand the logic I just explained? I didn't hear that. What did you say? Okay. I don't know why your line is always broken. So if I integrate y squared with respect to y, I will have y raised power 3 over 3, right? Y raised power 3
Yes.
over 3. Then I will have plus half. I can put this plus half. Then if I integrate x squared with respect to y, you know x squared is a constant. I'll just give x squared here. Since x squared is a constant in that regard. So what is the integral of dy? It is y. So I will have half x squared y. Now I'll put this half here also. You know this 2 is going to cancel this 2, so I don't need to write the half. So this 2 is going to cancel this 2. So now I'll put x. No, y is the constant. I'll put y here. So if I should integrate x, so let me just cancel out this. This 2 cancel this 2. So if I should integrate x with respect to x, I will have times what? X squared over 2. Integral of 0 is a constant. Say c. So a constant c. So by the time I simplify this, I have y cubed over 3 x square y over 2 plus x square y over 2. That will give me x square y. So that x square y is equal to c. So this gives me the solution to my problem. Do you understand?
Yes.
Okay. Now using the comparison method, I can just say use this guy, this formula I already written here to find to solve the problem. So if I'm using that, let me erase this part. So I don't need this one. So f is my solution. So f is my solution. So my f will now be equal to integral of m dx. What's my m? 2xy. I'm going to put the bracket. So integral of m dx, that's 2xy dx plus integral of into bracket n. My n is y squared plus x squared minus d dy of integral of m dx, that's 2xy dx, close bracket, there is respect to what? Y. So this is now equals to, if I integrate this guy just to x, I will have xy squared over 2. So x squared y over 2 rather. X squared y over 2. But x squared y over 2, that will cancel this 2. So that is fine. So I will now have plus integral, put into bracket, y squared plus x squared minus the partial derivative with respect to y of what? Of integral of 2xy dx, that's x square y then put this one dy like this, then continue. I will have x square y plus integral of y square, then put inside bracket y square x squared minus differentiate x square y with respect to y. I will have x squared, right? Close bracket dy. So I have this to be x square y plus integral of y, x square minus x square that was already cancelled, so integral of y square dy. This is not going to give us x square y plus, if I should integrate y square with respect to y, I will have y cube over 3. So these stuffs are problem. Is it the same thing as what we got for the grouping method?
Yeah.
So do you understand using this formula, or I should go from maybe the usual, like the step-by-step process, instead of having to use this formula? You know, having to use this formula means that I must know this formula by heart, but you know, I apply the step of the process to get to this formula. So do you understand? You understand the process to get to this formula, right? I didn't get it. What did you say? What did you say?
Nothing.
Okay. So I'll go to the process of that we use to arrive this formula to solve this problem, instead of having to use this formula as what we have generated here. So I'll use that process. I'll erase this. I hope you have written this. I can clean it.
Yeah.
Okay, now, so you know, recall that if f is the solution to this guy, so it means that df dx will be equal to what? M, and df dy will be equal to n. So I can start my manipulation from here if I like, or I can decide to start from this guy. I will link both of them up at the end. So if I'm starting from here, if I'm using this, so I'll say if del f del x is equal to m, how do I get f? So I'll say if del f over del x, if del f is equals to m. What's m? 2xy. So how do I get f? I'm going to integrate both sides with respect to what? To x. So if I'm integrating a function of two variables, I'm going to have, so with respect to x, so I'm going to have integral of 2xy dx. So I'm integrating a function of two variables with respect to x. It means my constant value is going to be a function of the the remaining variable that I'm not integrating with respect to, which is y. So I'm going to have my constant to be a function of y. So here I'll have that what? I'll have that f is now equals to integral of 2xy with s to x will now be s square y, right?
Yes.
Plus that function of y. Now, so I've used this guy from this place. Now I have to link to this place now. Now how do I link up? Since my f is this, I'll now use this condition now. I'll now say if I differentiate this one with s to y, I should have what? N, and I know what my n is, which is this. So I'll now say the f dy that is differentiating this one that I generated here with s to y will now be equals to differentiate s square y with s to y. I'm going to have x squared plus if I differentiate phi of y with s to y, I will have phi prime of y. And don't forget that it is stated here that the f dy is got what? N. So this should be equals to what? Y squared plus x squared. Are you following?
Yes.
So if I have this scenario now, I'll just have to link up this part of the equation, these two. So from here I'll continue. I'll now say make phi prime of y the subject of the formula. So phi prime of y will now be equals to what? Y squared, because s squared will cancel s squared, right?
Yes.
So if phi prime of y is equals to y squared, how do I get phi of y? So phi of y is going to be integral integral with s to what? Is s to y. So phi of y will now be integral of y squared with s to y, and that will be equals to y squared over 3. Sorry, what am I saying? Y cubed over 3, right? So since I've gotten phi of y, what I just need is what? To substitute here to get my f. So that implies that f is now equals to, so sorry, if I integrate raised to y, I have y cubed plus over 3 plus c, I have a constant variable. So my f is now equals to s squared y plus y cubed all over 3 plus c. So apparently that's just how to go about it. Do you understand? Okay. All right. So now let's take a look at which one should we look at in again. Which one should we look at? Number what?
Four.
Okay, number 4. So you help me to dictate this guy. So can I erase this? Can I erase?
Yes.
Okay. So let me erase this. I actually forgot I have a class this evening. I actually skipped my mind. I would have. You know that I'm usually staying up late at work. That's why you just. I didn't even have, because it didn't even cross my mind. I didn't I went home early. You just come like, I'm inside. You didn't allow me. It will just be a funny scenario, seriously. So can you dictate the question for me?
Okay. Bracket 2x plus y
Okay, 2x plus y
plus 3xy
plus 3xy.
plus 3x square y.
Okay, 3x squared y.
Yes.
Close the bracket.
Yes. Then dx
Okay,
bracket open x cube
x cube plus
x squared by y
x cube plus x squared sin y.
minus x squared sin y
Like this.
minus y. After x squared sin y is minus y. After x
Okay, minus y.
y.
Easy question, right? Okay, so let's try and look at this. Um, so let's use grouping method. So let's use grouping method first. Grouping method. So you have to first of all, let's verify whether it's an exact equation. So we take m to be the one that the guy with the dx. So our m is going to be 2x cos y plus 3x squared y. Then our n is going to be x cubed minus x squared sin y minus y. So to check whether it's exact, we do we differentiate m partially relates to y, so that we can have differentiate this partially relates to y. I have minus 2x sin y plus 3x squared. Okay, then I will differentiate n partially with respect to x. So I'm gonna have 3x squared minus 2x sin y. This implies that they are exact because obviously we have the same thing. So since my equals nx, then the dE the differential equation is exact. Is exact. Yeah. So the next thing, since it's exact, we proceed to solving the differential equation. So now I will say using grouping method. So let's use grouping method. So using grouping method, you are going to expand this guy. So if we expand this guy, we're going to have 2x cos y dy plus 3x squared y dx plus x cubed dy so let me see, minus s squared sin y dy minus y dy. Let me just put equals to c, since I'm going to be adding integral to both sides. So equals to c. So you're going to put integral like this, integral, then integrals. So you just integral is so down. So would I put half here? Okay, I'm going to put half here. Would I put half here too?
No.
So why do you think I'm not going to put half?
Component of there's x and here.
You can see that there is y here. So if you have dx and there is a y, there's another variable that there is not x, you have to put half. So that's why you have to put half here. So half has to be here too. This one you have dy, there is a x, so half have to go here too. Yes, also half has to go here because you have dy and there's an x component there. So half is going to go here. Here you have dy. You have just y. There's no x component. Then this one is fine. Do you understand? Okay, so let's proceed to solve. Now here, two is going to cancel 2, so this one is gone. Which one again? Okay, that's all. So let's start. So take this one, I'm integrating x to y, so x is a constant. So if I integrate cos y raised to y, I'll have sin y. So I'm going to have x sin y. Then here I'm going to have plus 3 over 2. I'll bring out plus 3 over 2. Or before then, integrate, because I'm integrating x to x, y is a constant. Integrate x cubed, sorry, x squared with respect to x. That will be x is power 3 over 3. So that 3 under is going to cancel this 3. So I'm going to have as 1 over 2 s cubed y. Right?
Yeah.
Okay. Plus, now this one, x is a constant. So integrate dy raised to y, I have y. I'm going to have s cubed y also here. Have x cubed y. Then here also, here x is a constant too. So I'm going to have plus. So if you integrate sin y raised to y, I will have minus cos y. So that minus is going to affect this this minus half that I have is I have plus half x squared plus y. Plus y like this. So here minus integrate y raised to y, I will have y squared over 2. Is equals to c. Then I will just simplify this. So if I simplify this, x sine y, okay, this is still good. So I have x sine y then this plus this give me plus s cube y. Then I have this, that's half x squared cos y. Then I have minus y squared over 2. Which is equal to c. Okay. So this gives us our final answer. So I want to bracket this so that you can compare with what we have in our second method. So now the next thing we do is now we are not going to use our comparison method to solve this problem. So I'm going to erase this. Can I erase this?
Yeah.
Okay, so I'm going to erase this now. Then I will now say okay using I don't know this part. So now using remind this guy comparison method, that's CM. So you know the rules, df dx, so f is our solution, so df dx is m, df dy is n. So let me just write it out here. If f is our solution, df dx is equals to m. So always be sure of what you are writing about your m and n. Make sure your m is the one that has dx, your n is the one that has dy, so that you won't get it twisted. If you are accustomed to what I'm doing, what's this method? So you don't change your n and don't change your y, so that, but you can just understand the logic. That's okay. Whenever I use this one, then that's basic. So if I'm starting from this now, if my df dx is m, my f is going to be integral of m with respect to x. So what's my m? That's 2x cos y plus 3x squared y plus 3x squared y dx. So since I'm integrating raised to x, I'm going to have a constant value which is a function of y. So I'm going to add phi of y here. So if I have this, I can now proceed to say, okay, my f is now equals to what? So integrate 2x cos y raised to x. Anything regarding to y is a constant. So I'm going to have x squared cos y, right? X squared cos y x squared cos y. Then this one I'm going to have plus s cubed y s cubed y then plus phi of y. So I've used first condition. So the next thing is to differentiate partially with just y. So using this condition. So I'll differentiate this raised to partially raised to y. So df dy from there. Yeah, this is my solution. But what I need to find is this phi of y. So df dy will now be equals to, differentiate this partial raised to y, I'm going to have minus s squared sine y sine y plus x cubed differentiate phi of y raised to y, I will have phi prime of y. And we said that df dy is what? Sorry, I didn't state it here. Is equals to n. So that will be equals to, what's my n? This guy. That will be equals to s cubed minus s squared sine y minus y. So considering this, I'm going to make phi prime of y separate of the formula. So you can see that this one will cancel out this one. This one will also cancel out this one. So I can have phi prime of y to now be equals to y minus y. So if phi prime of y is equals to minus y, what's now be phi of y? Integral of this with respect to y. So that phi of y will now be integral of minus y dy, which is equal to what? Minus y squared over 2 plus 3 minus y squared over 2 plus c. So my final answer is now to substitute phi of y into this place. So f is now equals to, so let me just use a paper. F is now equals to s squared cos y plus s cubed y minus y squared over 2 minus y squared over 2 plus c. So apparently it means that something went wrong here. There's something we did wrong in this place. There's something we did wrong in this place. You can see that it's not the same. So I actually observed. I actually observed that, but I don't know. I did something wrong. Do you know what I did wrong? What I did wrong is that, if I expand this guy, this one's going to have dx. Instead of me to integrate with s to x, I integrated with s to y. That was why I add. So that's why I add this x and y here. I'm supposed to have x squared. I'm supposed to have x squared cos y, so that like half x squared cos y, so that this is going to add up with this. Then I'm going to have this result. So if you work your way around that, you're going to arrive at the same answer. Have you seen the mistake now? Yeah. So you're supposed to have the same answer. So that's basically. So can we move to the next agenda? What's the next agenda? integrating factor. So yeah, integrating factor is the next agenda. So that's when we talk about equations that are not exact. Equations that are not exact. So please give me a few minutes. Give me a few minutes. I'll be back.
Okay.
So are you there? Hello, Palmi. Okay, I think you're there. So inexact equations. So that's where integrating factors come into play. So it's actually interesting, you know. So so talking about Benelli equations also and a lot of them. There are so many methods of finding integrating factor. It also depends on your M and N, whatever. Depends. I don't know what I'm thinking about all of these things. Okay. So it's a find integrating factors to make the following ordinary differential equation exact and hence solve them completely. So there are two common ones. Then there is this, I think, two other ones. I can't really remember every one of them, but obviously uh, we're going to talk about we're going to talk about it. So pick one question here. So it's just to get the idea. Pick one question between 1 to 8. Are you there? Number 6. number 2. Okay, number 2, I have x plus y, x minus y. X plus y, x plus y dx. Abi? Minus
Yeah.
x minus y dy equals 0. So, how do we solve this guy? So, what's our m? Our m is x plus y. Now, your n is minus into brackets x minus y. Or we can just say this is equals to y minus x, right? All right. So to show whether it is exact, you are going to find my, differentiate m raised to y. Let's see whether it is exact. So my is equals to 1 and nx is equals to minus 1. Now, they are not the same. So they are not the same. They are not the same. So how can you make this guy exact? So how can you make this guy exact? Apparently, in this case scenario, you can use, since both of them are just constant and you integrate them, you can use any method. You can use this guy. Say, so let's check this guy, how this one works out. So let's check my. So let's check my. So let's use my over m minus n. So let's check this guy. So let me say if, which is integrating factor. So let's check this guy. So that will be what? 1 all over x plus y minus, that will be plus x minus y, right? That should give us 1 over 2x. Yeah. Are you still with me? Apparently, whenever you use this guy, whenever you use m as a criteria, like in this kind of scenario, your integrating factor is going to most likely convert to a function of x. You can see it's a function of x. But if I'm using n, it's most likely going to convert to a function of if I use n here, I'm going to use, I'm not doing n minus n in this case, so it's going to be nx all over n minus m. So that will be minus 1 all over y minus x. This is my n minus x minus 1 minus y. So this does give you, you can see here, if you use this one, it doesn't work out the way we have really wanted it, because y will also cancel out outside a function of x. So you might not necessarily want to use this guy instead. So you might not necessarily want to use this guy instead. So let's just forget about this one. So this one suffices. So if I have this guy, so this guy is going to be an integrating factor. So how do I make use of it? I'm going to multiply this my original equation. I'm going to multiply all through by this integrating factor to make it exact. So if I do that, I'm going to have x times 1 over 2x, that will give us 1 over 2, right? Plus y all over, or just say half, let me just write that. So let me just put y over 2x, let me show it, y over 2x, y over 2x to y dx, then minus into brackets, this is going to give us x all over 2x, that's 1 over 2 minus y over 2x. Yeah, minus y over 2x. dy is equals to 0. So apparently you are going to, so here if I'm solving this problem now, if I want to check whether it's exact, my m now will be half plus y over 2x, and my n is going to be y over 2x y over 2x minus half. Now if I check this guy, it's not going to be exact if I use this guy. So if I use this guy, it's not going to be exact. So my is 1 over 2x. Then if I say nx is what? Is like minus y over 2x squared, something like this. It does not make sense. So this guy is not going to be exact. So it means we are not getting how we're going to make this guy exact in this way. So one thing you also look out for is that before you do this, okay, fine, your m is this, your n is this, but then if you check it, this your equation that you are given, it's an homogeneous equation. So whenever you have an homogeneous equation, there is a different condition. So can you help me with something? There's a particular page in your booklet that has these conditions for integrating factor. Can you just snap and send that part to me on WhatsApp so I can take it up from there? Do you understand? Okay, thank you. I'll be waiting your message. All right, so let me just, can you see my screen now? Okay, so, okay, let me pick it up from there. So, where is it again? Okay, yeah, exactly. So if you look at this guy, you, so if you look at this guy, you see a condition here. Let me enlarge the screen. So if you see number 3, say if equation 1 is known to be homogeneous and that it can have something like this, then you can have something like this expression. If that's not the case, so but if you have this, then your integrating factor is going to be exponent of integral f of x. So in that case, this is what we are going to use in our so if you have the my minus mx over n to be this, or my minus nx all over m to be minus g of y, then your if is going to be this. So apparently we won't be able to use this homogeneous condition because we can't write our equation in this format. So we are still going to use this particular one. It's been a while. So let's go back to our question again. So apparently we are going to use my minus nx. So let's check my minus nx over n. If we check this guy, that's according to what we have here. Where is it? So according to what we have here, if we check this guy and it gives us a function of x, then we can use that. If we check this one, this is a function of y, but apparently it's not going to give us that because my minus nx is 2. 2 over x plus y is never a function of x. If we should use the second one, say m minus nx all over m, it can give us a function of y only also, so we cannot use that also. Number 3, can we use number 3? Can we use number 3? No, you can't use number 3. So can we use 4? It said if equation can be written in the form this. So our problem, this problem cannot be written in this form also. So we can use 4. Let me check. Where's the next one? I think I opened it, both of them. So let me check. So let's check this guy. So for for the given condition for 4 is this one, but yet is still not satisfied. So the condition is not satisfied. But if you look at the problem, what is the problem saying from here? It's just saying that find the integrating factor to make the following ordinary differential equation exact and else solve the problem. So in this case, we don't have a case scenario that makes this guy exact. You don't have a case scenario that makes this guy exact. So apparently we cannot make this guy exact in a way like that. But if you look at this guy, there is no need for me to use whatever maybe exact or because this is an homogeneous equation. I can solve it using the homogeneous equation method. That is y is equal to bx. So there's no way I can make this guy exact the way they are. We would have loved to make it work, but apparently we can't do that here. We won't be able to do that. Do you understand? Yeah. So you can just use the normal homogeneous equation method, that's substitution method. So y equals to bx, then you have your way. So let's look at the next question. Which question should we look at now? Number 1. Okay. 2y minus 3x dx plus x dy. 2 minus 3x dx. So I will have 2y. So I will have 2y minus 3x dx plus x dy is equals to 0. Right? That's what we are, right? So our m is 2y minus 3x. 2y minus 3x, and I have my n. I have my n to be x. So what do I find? To check whether it's exact, I'll find my. That's going to give us 2, and nx is going to give us 1. So apparently this guy is not exact because they are not the same. So how do you make this guy exact? Yeah, so you can make this guy exact using my minus nx over n. I can't use over m because if I do my minus nx, which is 1, if I divide by m, it doesn't simplify it in any way because I'm going to have a function of xy. But if I divide it over n, I'm going to have a function of x. So I'm going to use my minus nx over n, and that's going to give me 1 over x. So that my integrating factor is going to be exponential integral of 1 over x. Exponential integral of 1 over x dx. And that's going to give me exponential ln x. And apparently exponential ln x is going to give me x, right? So after I've gotten my integrating factor, all it does is just to multiply 3 by my integrating factor, that's this original equation. So if I do that, I will have 2xy. I'll have 2xy minus 3x squared dx plus x squared dy is equals to 0. So we check again. Is it exact now? So m is going to be 2xy minus 3x squared and my n is going to be x squared. Then what would I do? I would differentiate n partially related to y so that I can have 2x. Then I would differentiate n is related to x partially. So here I can also have 2x. So in this case, you can see that my is equal to nx. So the problem is now exact. So since the problem is now exact, it's now left for you to what? To solve this guy using maybe grouping method or comparison method, and that's all. So it's just for you to make it exact. So when it's exact, then the problem is solved. Then you use grouping method or comparison method. So I will not go into that. So let's proceed. So I believe we can proceed with that from there. So which one should we look at again? Number 5. 5, right? Okay, number 5, I have 2y minus s cubed dx. 2y minus s cubed dx plus x dy. This one is also going to be very simple and straightforward. Our m is going to be equal to 2y minus s cubed. My n is going to be x. Let's check, is it exact? My my will be 2. My nx is 1. So it's not exact. So apparently I'm going to use this one too. If I'm going to divide by n, I'll do this minus it divided by n because that would be more compact to use. So my minus nx is going to give me a constant divided by n. So here I'm going to have 1 over x, which is a function of x. So my integrating factor will be the same as what I have here. So my if in this case is going to be x. So if I multiply x from with this original question, I'm going to have 2xy minus x is power 4 minus x is power 4 dx plus s squared dy is equals to 0. So if you check this one now, it's going to be exact because this m is just y, I have 2x. You change this one against x, I have 2x, so it's exact that way. So let me erase this. Let's look at one last question from your end, and I will look at maybe a question inside the past question. Probably one question. Maybe I can find one question inside the past question. So it might not necessarily be in this page or on this page that I'm choosing from. You can have maybe. So one last question to look in from here. Number 7. Question 7, right? I didn't hear you. I didn't hear that. Okay, question 7. So I have y into x plus y dx. Y into x plus y dx. Let me check again. Yeah. So y into x plus y dx minus x squared dy is equal to 0. Minus x squared dy is equal to 0. If you check it very well now, I'll tell you what this one satisfies. First of all, this guy is an homogeneous equation. Why? Because if I should expand this, I have yx plus y squared dx minus x squared dy. They are all of the same order. All of them are of the same order. Yx, that is y times x is xy. Xy is like a power of 2 because x is power 1, y is power 1. So combined power of 2. Y times y is y squared, power of 2. X squared, power of 2. So they are of the same order. So it's an homogeneous equation. And it's an homogeneous equation, and you can also write it as y times something dx minus x times something dy. That is x times x dy. So if you look at this condition of let me check it again, of integrating factor. So where is it? Coming to, where do I have it open now? Let me just open it. So factor. So opening this guy. To check it, look at if equation 1 is not to be homogeneous and you can have x times m plus y times n not x times m plus y times n not equals to 0, then the expression blah is an integrating factor for your homogeneous equation. So first of all, our equation is a homogeneous equation. So we put that at the back of our mind. Now, if I can do this guy, if I can perform this expression, I can now check, is it equal to 0 or so you check it, is x times m plus y times n. If it's not equal to 0, then we are going to use this condition as our integrating factor. Also, I said if you can have the expression in this form and f of x is not equal to g of y, then you can use this formula to be your integrating factor. That is, so you can say what this is. So then the expression 1 over blah blah blah, which is equal to 1 over mx minus ny is your integrating factor. So in that case, I think our expression can be written as this guy. So we can also use 1 over mx minus ny as our integrating factor. We can also check this one, so this one that is saying that 1 over x times n plus y times n. So let's check both of them. So coming back. So so if you check it now, so let me just erase this guy. So if you check it now, this is like y times, so let me just y times a particular f of xy dx. Let me check again. Plus g, so let me say plus x times g of xy dy which is equal to 0. But in this case, my f of x comma y and my g of x comma y is what? This is x plus y, and this will be what? Minus x. Do you agree? Now, so I'm using this last condition, this one that is here. So what? So if you look at f of xy and g of xy, are they equal? No. Then this condition is satisfied. So what do they call our integrating factor if we have this kind of scenario? We said our integrating factor is going to be 1 over mx minus ny. So what's our m from the original equation? Our m is xy plus y squared. Xy plus y squared. Just open the bracket. Plus y squared. And our n is minus s squared. So in this case, using this condition, our integrating factor is going to be 1 over mx minus ny. Mx minus ny. That implies I have 1 over. If I differentiate this one raised to x, what do I have? I have y. If I differentiate this is raised to y, what do I have? I have 0, right? Plus 0. So it means my ix was 1 over y. 1 over y. So my ix is 1 over y. It means for me to make this guy exact, I'll multiply all through by 1 over y. So multiply all through by 1 over y, I'll have x plus y dx minus s squared y. So s squared over y rather dy is equals to 0. But if you check this now, if you check this, it's not going to help our situation because I don't think this is going to be exact in. Is it going to be exact in any way? Okay. Okay. So let's multiply out by y. So I'm going to have y like seriously. It's actually it's like we are going back to the question. It's like about because I multiply out by y. I'm going back to the question. Can you see that? It's like I'm actually going back to the question. So, this is, let me check what the condition is here. He said this is the integrated part. So let's use this part and not this part instead. So let's use maybe what you were trying to, maybe this is not mx, maybe you wanted to say my minus nx. Maybe you wanted to say my minus nx because I don't see so let's use my minus nx instead. What is that? All right, so let's use my minus nx instead. So that would be good. If I'm using that, I'm going to have if. So using if is equals to 1 over my minus nx. So that would be equals to 1 over. So that would be x plus 2y minus 2x, right? That would be equal to 1 over 2y minus x. I hope this is not going to complicate issue. I hope this is not going to complicate. So don't let us use this. So let us use that of the homogeneous equation. So since it's an homogeneous equation, so since is an homogeneous equation, so let's check whether xm times yn is not equal to 0. So xm, so x times m, that will be x times xy plus y squared. Then let's say plus y times n. So y into what's my n? That's minus x squared. So let's check whether it's going to give us 0. So that will be x squared y plus xy squared minus s square y. So this one will cancel this one, but it's not equal to 0. So it's not equal to 0. So this condition is satisfied. So if you have checked that it's not equal to 0, they said our integrating factor would be 1 over xm plus yn, right?
Yeah.
Okay, so that should be 1 all over, so that will be this guy, right? That's what you have here. That will be 1 over xy squared, right? So if that's the case, so it means that I have to multiply all through by my integrating factor. So multiply all through by my integrating factor, I'm going to have x over y plus 1 over x dx plus 1 over x dx minus x over y squared dy. This is equal to 0. Do we understand this stage? Hello, do you understand this stage? So our new m now is now equals to x over y plus 1 over x. And our new n is now minus x over y squared. To check whether it is exact, we are going to find my, that is differentiate partial derivative to y. So if we differentiate partial derivative to y, what do I have? I will have minus x over y squared. Right? Okay. So if I should have that. Oh, I think I made a mistake. Sorry. This part is not x over y, it is 1 over y. It is 1 over y. Because this is xy. Y times x is xy. X would have cancelled this x. Y in y squared is y. So I have 1 over y today. So this is going to be 1 over y plus 1 over x. 1 over y plus 1 over x. So if I differentiate this raised to y now, I will have minus 1 over y squared. Hope you are following.
Yeah.
So this is going to be minus y over y squared. Now let's differentiate n with respect to x. Y is a constant here, so I'm going to have minus 1 over y squared also. So you can see that the equation has been made exact using this integration factor. So in this case, so what we just learned that in this case scenario, if you have this condition 1, if you have this how am I saying the same thing at the same time? So if this condition 3 is fulfilled, don't go to condition 4. So you just use this condition 3 to find your integrating factor. So since we have found our integrating factor, it's an homogeneous equation, and this is not equal to 0, then our integrating factor is equal to 1 over whatever you get here, which is this. So apparently that's that. So I think the final thing to talk about is the, so don't bother about this one. So 5.7 is talking about, okay, we have Bernoulli, we have linear equation. So I don't think we will talk about this today. So on Monday we are going to talk about Bernoulli equation and linear equation and Bernoulli equation. So it's very simple. It's nothing difficult with linear equation and quadratic. They're even the sweetest kind of differential equation you should be interested to solve. Like, it's very simple. So I hope we all understood what we did today. I hope you understand what we did today. So in the next class, we'll be talking about linear equation, linear differential equation, and Bernoulli. This is how to spell Bernoulli differential equation. Are we clear on this? All right. So let me stop sharing and stop recording.